So sorry you couldn't make it in person. There's 27 pizzas. No. So anyways, tonight is going to be a little bit of an overview of Azure Synapse Analytics, and specifically talking about the lakehouse capabilities. So lakehouse is kind of a term that our friends at Databricks will say they came up with, but I'm sure other people have claims to it. And where Synapse kind of fits into that picture. But to really kind of get down to start to explain that, we have to think about the history of legacy on-premise data warehouse. And this pattern's been around for a long time. It's been around for 20 plus years, where you have a bunch of on-prem data sources or data sources of the data centers, maybe some CSVs. You do some kind of ETL process into a staging database. This might be, also stored in an ODS, an operational data store, and then further downstream inside of its SQL data warehouse, where you might do some kind of dimensional modeling, and then serve it up using a variety of sources. Excel probably being the most popular business intelligence tool out there for years. The challenges with this is that it's scalable and it serves up good sort of end reports. It's relational. It's good for tabular and columnar data, but it's terrible for, it's not ideal for JSON or clickstream or unstructured data. Change to the data warehouse can be time consuming because you have to define the schema on write. You have to know how you're going to write to the table. You do that modification. It also is difficult from the perspective of everyone's favorite topic now, data science and machine learning. There isn't enough. There isn't a good way to put the kind of quantities of data that you need inside of a relational database, and to give people unfettered access to that for machine learning and data science, and then pull that back in for consumer and the self-service user. So this is where I kind of get to kind of the next stage of where I see three kind of data consumers out there, and they have an inverse relationship to the size of data versus the count of consumers. And the majority of the consumers that you would have in your data state would be the report consumers. They're grabbing your published reports, whatever the case may be there, and they're just reading. They're not really doing much with them other than just consuming them and deriving some sort of business value. Then you have everyone's favorite topic, self-service BI, and maybe they're going to be doing that as well. They're going to take those reports, and they may mash them up with a data warehouse and maybe an operational data store. And then your data scientists, and the data engineers, as I should probably call that out as well, they want it all. And the traditional data warehouse really struggles to serve all three of those two issues. One is the volume of data, to serve that data science and to some degree the self-service user, and velocity of refresh. Well, to refresh the data, a little more complicated to refresh the data, as well as land new sources of data in your data warehouse, because you have to find schema ahead of it. So introduces kind of the modern data warehouse that we've been talking about for years, and kind of prior to this, a lot of these concepts are built on Hadoop, where you have the kind of the four columns there, just prepare, transform, and serving layers off of a data lake storage or some kind of HDFS compliant big data storage. So I'm going to get kind of Microsoft specific here. In this case, we've been doing this pattern for years, where you have your on-premises and your cloud data using Azure Data Factory Gen 1 and then Gen 2 to land that data as is inside of a lake, using Azure Databricks and Azure Data Factory again to do either low code or code first transformations on that data, enrich it, and then land that in some kind of storage area, like an Azure SQL Data Warehouse or Azure SQL Server, depending on the size, and serving it in Power BI. So it's been around Microsoft for a few years. You've been talking to a data person. You probably have seen some variation of this slide. It's a common pattern. Challenges on it could be that it was difficult to wire these things up. You had to think about authentication across all of the services, and this pattern became so common that kind of the product group took it to the next step in kind of encapsulating those four columns into Azure Synapse Analytics, which, as you'll see here, is not really a single product, a suite of products inside of a single pane of glass, which we'll talk through here. So when we think about Synapse, first off, it's a platform and not specifically a product itself. It's a platform of products together. First off, it's underpinned by Azure Data Lake storage. So when you provision a Synapse workspace, you can either attach it to an existing data lake store or create one there. I'll get into the details of these. Within the platform itself, we do data integration. So the Azure Data Factory piece that we had and still have in Azure Data Factory is essentially the integration piece of Synapse. More or less, I couldn't say this even a few months ago, but more or less the integration piece of Factory and Synapse integrate are identical in terms of capabilities. The next part of this are our analytics runtimes. So we have SQL Server, that's traditional SQL as well, traditional SQL semantics on what's called a dedicated pool and also a serverless pool, and I'll get into the difference between the two, as well as Apache Spark, open source Spark right now, built in here, which is kind of analogous to what you were doing in Databricks. Two different form factors for this. We have dedicated SQL pools, which are essentially just SQL data. Use Azure SQL Data Warehouse, that's what that is. Serverless is a new kind of paper query capability built with an engine that has a lot of promise. I've been meeting with customers for all our data warehousing and data exploration scenarios, and we'll look at the use cases there. It's a really interesting feature that I'm going to focus some time on when we get to demos. We also kind of support all of the languages where you are. SQL, Python, .NET, of course, .NET's for Microsoft. I think Microsoft is one of the larger contributors now to the Apache open source project, and one of the show I made sure to pull that out, as well as Java and Scala, kind of the original. Across the top of that, we have our Synapse Analytics Studio, which if you use Data Factory, you're going to recognize the UI. And then, we have AI built in, ML built in, we have some pre-trained models, built into Synapse Analytics, the ability to stream data into it. So there's a lot of capabilities here in terms of serving up kind of your one-stop shop for analytics at Microsoft. Moving on from here. So when we think about that modern data warehouse slide that I showed you before, how do you do in Synapse? This looks more or less familiar. Where you have, your on-prem data sources using Synapse Pipelines to place the data lake, using Synapse SQL Serverless to do transformation there. If I can look at that here in a minute. Synapse Pipelines is low-code data flows capability, enriching and transforming that data with Synapse Spark or Synapse SQL or Synapse Serverless. One thing we won't ever be accused of at Microsoft is offering you two options, and sometimes that's actually an hindrance. There are too many ways to do things. So when I draw this out all the time in my role, and I kind of draw across the top where I think you should go, and it really kind of depends on the persona I'm talking to. If I'm in a room full of Spark developers or .NET developers, or people comfortable with Java or Python, all day long do your data transformation. But maybe you're going to be hiring or bringing a group of folks that have used tools like Incremental or SSIS, or any other UI-based ETL tool. And if you just throw Python in front of them and say, hey, now you're going to do all of your data engineering and ETL or ELT in this case using Python, they're just going to go find another job. So we try to offer you the capability to do what you've been doing all along, in a familiar experience to kind of accomplish the same thing. So, I've had customers use all three of these capabilities. So they have people more comfortable doing transformation in stored procedures and doing it that way instead of a dedicated tool for their data flows and so on. Some people may use Spark, some people have Databricks and reasons they're valid. So all that to say, this isn't the canonical architecture where you have to do it no way. And what's interesting about Synapse is once you provision a studio workspace, is that you can just choose the pieces you want to use. you turn this thing on, I have a Synapse logical data warehouse built out out of my little $150 a month MSDN account, and it works fine. And I can do a lot of the stuff in here, especially using some of the serverless capability. So I only have about 15 slides here, so we're not going to be on the slides. So a little bit of overview of the studio. When you vision Synapse, you get this studio experience as well as a few different endpoints, which I'll show you when we get it out. On the left-hand side, you'll see that it's kind of split up into some task areas, what we're calling activity hubs here, where you have your data hub, development hub, integration, monitoring, and management. All this is kind of inside of the same workspace. So we'll kind of walk down the stack and explore each one of those at a high level. And I'll probably talk more about them as we get to the demo and I start showing this stuff that's nice. So Synapse Integrate, right? And some people call the Synapse Pipelines. I'm just trying to be, video, I'm just calling it Synapse Integrate. We also use the word pipeline in about 20 different places here at Microsoft. So maybe it's because we talked about Synapse Integrate. This is essentially just Azure Data Factory. Until, like I said earlier, it used to be a little bit different from ADF, and it's still running a little bit behind inside of Data Factory, and I'll point out one area where it is later, but for the most part, it's 99% there. Even customers that I've had that start off brand new, unless they have a specific reason to use ADF or just to use Databricks, it's okay to just start with Synapse and just use the integration piece there because of some cool integration pieces with Synapse Serverless, which I'm going to show you here in a minute. The ability to spin up things and having some nice authentication built in. But like I say, there on the bottom right-hand side, this is Data Factory. It has 90 to 100 connectors now. This is where you're going to be doing your ingestion, your transformation if you use the data flows piece, which we'll talk about, and loading of your data. Right? So this is all about data movement. It is a very mature tool now, capable of parameterization that allows extremely flexible pipeline development, just to allow you to use one or a few pipelines to perform thousands of different tasks to ingest and loading your data by a metadata-driven approach. So that's the integration piece, that left-hand column in the kind of architecture there. The next part is the data hub, right? So inside the data hub, typically here we're looking at the link data hub, and you're going to see all kinds of stuff here. Cosmos DB, that's part of Synapse Link, which I'll show you. See there on the bottom, where it says, the linked AWS Gen 2 account. This is the account that's kind of the primary file system for Synapse. But you could also add in other things like other data, like storage Gen 2 accounts, blob storage accounts. So you can have all of your data in here to be querying and kind of bringing together in an easy way. Quick primer on Azure Data Lake Gen 2. It's polyglot storage. You can store whatever you like in there. It is essentially an HDFS endpoint on top of Blob. Azure Blob storage, you think you have folders in there, you don't, right? So every file's there in the system metadata about where it is. But this is a true hierarchical file system, so that we can do a file folder exclusion and go right to the file you're after. It's very, very fast and optimized for big data storage and processing. Azure Active Directory is built in using POSIX ACLs, so read, write, execute, and that /. Is meant to indicate the hierarchical file system. I probably should have spelled that out. But the common way we store data inside of a big data system, especially if it's row-based data, is Parquet, which is a highly enhanced, sort of think of it as CSV, but highly enhanced with schema built in and so on. And a new capability, new-ish, is the concept of Delta or Delta tables. This essentially applies ACID compliance on top of a more hierarchical file structure. So I'll be showing you a little bit of this. They also have storage tiering by policy built in the daily service. And by that meaning you can have 3 different tiers: hot, which is the quickest access and the highest cost of storage, and the lower cost of access. And we have cold, which is a little higher cost of access but lower cost of storage. And then also the archive tier, which is essentially offline storage where you see the file, but to rehydrate it, be able to access it, requires rehydrating. migration that can take many hours, but it's extremely inexpensive. And you can set that buyout policy very simply in your data lake, just by applying a kind of an age-based policy or whatever you'd like to do. Over on the right here, you're going to see a common way of organizing your data lake. And I'm using each one of those gray boxes represents a container in my lake, zone in my lake. And this is where I would start at the minimum for a Synapse deployment is some kind of idea of a raw zone, or as our friends at Databricks call it, bronze, and they came up with this lakehouse concept. This is where you store data as is. And down at the bottom, I have relational data, image data, JSON data, unstructured data, whatever the case may be. In your enriched or silver zone, you may be doing some data deduplication or some very light transformations, maybe solving small file problems. Small files combined into a larger one for performance reasons. And then your curated or gold zone, you may load a data warehouse from this, or you may actually do some dimensional modeling, star schemas, third normal form, whatever the case may be for organization. That's gold zone. And in fact, you can stop there and use the serverless Synapse endpoint to talk about and serve it up as a relational data store. Pretty interesting. All right, moving on in the stack. And again, this is kind of where I start with customers, who are new to this, is the low code approach. So our line on this slide is code-free data transformation, scale, data, and data flows. So I'll kind of break that down. Code-free in the terms that, and we'll look at a few of these for real, but code-free in the aspect that you see all these little activities in here, show data, join, match data. All the kind of common transformation capabilities are built into this that you might have in any other ETL tool like Informatica or SSIS. And there is some code to learn in there for sure, because we rely heavily on expression languages, which I'll show you, just as a way to really make these flexible. You don't have to use them, but you really do. You start to get into the at scale part of that is that we actually are running all this stuff behind the scenes on a Spark cluster. And I'll get into Spark here on the next slide. So it allows you to do extremely high-speed data processing across very large sets of data or small sets of data by you telling Synapse integrate to what size of cluster to use in the back end of this. And over on the right, if you're any Power BI people, you see Power Query there. Essentially, we also have data ranking or Power Query built in as an activity. And this also leverages that Spark cluster in the back end. Next, walking down the transformation column. We have built into Synapse open source Apache Spark. As of right now, it's a Spark 3.2 that just came out here a couple weeks ago for us. Support for that, along with Delta Lake 1.1 support. I'm not going to read this whole chart. The point here is this is a highly scalable compute engine for big data processing and machine learning. You'll do anything from data preparation to data engineering, loading your data warehouse, using a variety of languages. I would say probably the most popular one is Python. I'm going to show a .NET one tonight just because I knew we had some .NET people in the room. It also supports Spark SQL. So if you're a T-SQL person and you want to start learning how to use Spark or leverage Spark, you really can use a lot of very similar languages. It's going to be pretty comfortable. Use that same. If you're using Python on-prem, we have full notebook support here from Jupyter Notebook. Next, dedicated SQL pools, right? So, probably if you've been to a SQL Server user group here, or you've been to a presentation of any type that talks about Azure SQL Data Warehouse, or parallel data warehouse moved on-prem. Julie on the call, Gary knows about this. It's SQL Server at scale essentially. It's massively parallel processing. It's the evolution of Azure SQL DW. But if you're a SQL Server user and you have the right size of data, it's often the appropriate choice. I would say, we used to put a number on it, but I kind of get away from that. But it's in the multiples of terabytes, certainly, when you start to even consider that. And it's even more important to consider the size of your tables performance. You could also unplug this and put a Azure SQL Server in here, whatever you need to do. This is kind of your relational persistent data store. and it's built into Synapse. It's really kind of the core piece for very high-speed analytical style queries on a relational data set. The next piece, and probably one of my one of the things I'm most excited about, and I always like to show this, is the concept of serverless Sql Rules. And we'll look at this together here on the slides, but this is a paper query based off the size of data query service that looks and feels like SQL Server. You write T-SQL against it, you use store procedures, you use functions, you use views, but essentially it's a metadata database over your lake, right? So the idea is that you can query all these type of things with Azure Storage or Delta Lake, which is just Parquet, the log, Cosmos DB, Dataverse. You'll share metadata with your Spark pool. So if you create a database in your Spark pool, you'll see it show up inside of your lake database. You're able to break this across. It auto scales to paper use. It does automatic schema inference. So if you query a Parquet file on your lake, select star from open row set Parquet path. You don't have to tell it what the data types are, though that's probably a good idea to do in a lot of cases. And it's pretty fast. You'll see some pretty impressive performance, and you can actually scale this thing out, right? So you don't have to get into too much of a detail, but you can have multiple Synapse workspaces linked to the same backend data lake, each kind of providing their own compute on top of it. So something I'm pretty excited about. Can't tell. I'll show you a few. Another thing, and we're making a lot of investments here right now. We have a service called Synapse Link. If you I don't know how many SQL people in the room, I don't know if you I don't know Gary does. This is coming for SQL on-prem, SQL 2022, telling any tales out of school on that. That's kind of public knowledge. But the idea of the whole Synapse Link technology is the ability to take some other operational data store like Dataverse or Azure Cosmos DB and turn that column-based data into an analytical store. Use a column store essentially used for analytical queries. So on the back end, we'll actually be making Parquet files for you, more or less what we call real-time analytics. And so if you have a Cosmos DB database, turn on this Synapse Link capability, it'll just show up there. Synapse, you can sit there and query it, load it into your downstream data store. A really cool capability. A lot of investment on this. All right, so that's it for the slides. I haven't uploaded this deck yet to my repo, but all the demos you're going to see here in a minute are inside of the repo. Well, there's the deck that'll be on there later tonight or tomorrow. Any questions so far? Get some fun. Okay. We are going to do this. All right, so first thing I want to show you is get rid of that. Is when I go to, I'm inside of my, everyone in the room is the Azure Meetup referrals. You've probably seen the Azure portal. When you vision a Synapse workspace, you're going to see this whole thing. And I just want to point out one or a few different interesting things you might want to understand. So first off, you'll have your primary Ingestion 2 account that's attached to that, what the file system is, and I'll point you out what that means. Put your username, and you can do an Azure Active Directory. Here I have my username, but obviously you would probably have a group. But these, I should say, are the two things I want to dedicated SQL endpoint and the serverless SQL endpoint. What's cool about this, when we get into the serverless stuff, I'm showing you queries or creating views, is that you can just give anybody Excel or SQL Server Management Studio or whatever this address, and just have them query that like any other database. So those are kind of a couple of little admin things that I wanted to show before we get into the actual Synapse UI. So flipping over to that, Synapse UI. First thing is, here's a little tour. We have inside of here various hubs that I was telling you about, the data, the develop hub, the integration hub, monitoring and managing. one of the interesting things here, and I kind of like to show this right off the bat, is when I work with customers that are bringing in Synapse for the first time, is I make sure that they do some kind of personal. There is a built-in repository on this thing. Don't use it. Essentially, to save anything, you have to publish everything. Well, essentially making an ARM template. But you can register this Git repository to either Azure DevOps Git or GitHub. Either one, and those two. Something to kind of point out, and I'm going to apply here in a second. So let's think about the integration piece. So I want to do some kind of copying from on-prem to cloud or cloud to cloud. If you're used to Data Factory, this is going to be very familiar to you. Essentially, we have the concept of linked services. So linked services are, point out this one here, this Oracle one, information about what you are connecting to and what your authentication credentials are. Don't do what I'm doing here and put them in a literal. We use the Azure Key Vault, obviously. But you can see that I'm connected to an on-prem data source on my Surface Laptop 3 at home, which is currently closed and off. But if we're on, it would be pointing to a local Oracle database and a Docker container adjacent to it. But that's how you get to an on-prem. There's a couple different kinds of integration runtimes. There are three. There is the concept of a Azure or self-hosted integration runtime. So that's cloud movement and or movement from on-prem to cloud. And an SSIS integration runtime. Just drop packages in and run them inside of a managed compute cloud for you. So that's about the data movement. Linked services, like I mentioned before, we have some, I don't know what the count is right now. I would say it's at least 100. All of the common things you're going to connect to. And then if you don't have a specific connector, we can probably cover you there. There's no licensing or anything built into this. Just if you want to connect to something, we try to make it as easy as possible. So this is the integrate piece. So you have to obviously have something to integrate with. You got to set up your link service and your integration runtime to connect. Think about a simple pipeline. So I'm going to go to my integrate hub here, and I have a very simple copy demo here called an incremental copy pipeline. I'm going to hide all this. I am kind of blown up here. I'm on a small screen. So this has, it's a very simple pipeline. I'm using a watermarking activity. Look up, essentially the last time I copied a particular row, or what my last updated row is essentially in my target. My newest data is in my source. Copy data activity, one of the many activities you can do here on the left-hand side, instead of the pipeline, you can call out to all kinds of different services. And this is what I was talking about, very rich and pretty fleshed out capability here. So just copying, from left to right, using some basic parameterization on my source data set, out of the parameters that I did in my prior lookup activities to build a dynamic query, copy my data left to right. Simple copy pipeline. We have the capability to do debugging with that base. So if you are failing on this, or you're trying to do some kind of variable declaration, you can put a breakpoint anywhere. Say, hey, let me just debug this thing up to my breakpoint, and understand if I'm getting the correct output that I'm expecting. So pretty cool tool. The pipeline is the unit of scheduling, right? So I just did a debug there. I didn't have to publish it. But if we want to trigger or actually run a pipeline in operational status, you can put a schedule trigger on these things. I have a daily trigger. You can also use a tumbling window trigger or an event-based trigger to have these things fire off. As you can see, I did my debug here, and we have pretty good logging down here on the bottom-hand side. After I did my debug, you can see that I can look at my input and output for each data, each activity. My old watermark activity is I'm just looking at a single source, and you can see the output of that, input the next value where I'm actually looking for last modified time, and so on. So pretty rich debugging built with this. Of course, we will push this all out to log analytics where you would like to do external queries that way. something that I want to point out is that if you are not inside of it, we have full repo and here for Azure DevOps or GitHub. See what are you working in feature branch if you're going to be making changes. I'll show kind of at the end a simple CI/CD pipeline inside of here, but you can see what you have here is the difference between committing and publishing. Behind the scenes, this is just JSON. All of these, everything I have in here is just JSON, and it's all stored inside of my repo. If I go to my backend repo here, it's branch, my main branch, you'll see that pipeline is just sitting in there. It's going to copy pipeline JSON. So every time I hit commit, I'm just standing my JSON out to my back. When I hit publish, backhand side, I'm actually going to a hidden branch inside of my workspace and creating a new template to do an ARM template where you actually will do your promotion between environments. A little bit of a sidebar there on this. But this is why if you are not on a repo, you don't get this commit button. You have to publish every time you want to save, which is a giant pain in the neck. So a little bit of triggering, debugging, a little bit of monitoring on there. I'll show you a pattern from one of my colleagues that she wrote for one of our customers, and I just want to show you the power of these pipelines where you want to do essentially, this is all on GitHub, and I'll put in the notes because it's too much to go through for this conversation, but essentially 8 pipelines can handle any combination of source and target pair by ingesting through a metadata-driven approach where you just go to a table, and every time you want to insert a new row, you ingest a new table to your data warehouse, you just add a new row to the table, give it some information about the table name. Next time this thing runs, it picks it up, moves it in there, does all the schema inference for you. It's completely agnostic. Very, very powerful. But it just shows the capability of someone who's good at writing these kind of metadata-driven pipelines. It's a very common, activity or a common skill set for people who are good at ETL to use, and just kind of highlighted the capability there. And there's more to read that I'll add in the notes. Okay, so talked about the integration piece, and you can spend a lot of time on that. I'm going to move on to Data Hub. Data Hub inside of Synapse here. I've got a few different things that I mentioned. I'll show you inside of the linked space here. There's a couple different types of things. So inside of my linked Data Hub, I'm going to go to my Azure Data Lake Storage Gen 2. Now, as you can see here, I've got my primary one, this is the one that got created when I created my Synapse workspace. And I gave it a file system, which I call Synapse. And you can see inside here, I've got a few different containers, and I can drill down on these, and I can go in here and query these files. I've named them where they came from in source. This is where I can do things like manage access. This is where the whole concept of ACLs come in, positive style ACLs, and this is integrated with Azure Active Directory. Okay, so I can add in my user and add appropriate permissions in AD groups as well. So this is another kind of important thing, especially in the data lake, which can often become out of control, and you don't necessarily know what kind of data is there. Something you'll want to kind of keep an eye on. But we have also capabilities in here, as you can see, find something useful inside of your lake. You can add a new data flow or a SQL script or a data set on top of it, upload, download to it, and so on. But if you use Azure Storage Explorer, it has those capabilities, most of them, plus a few other things that are specific to Synapse. You can really kind of have this be your stop for storage management. Another kind of piece here, which I'll show, is that Synapse Link Cosmos. I have a storage, I have a Cosmos DB account out there. It has the Synapse Link feature turned on, and I have this movies container out here, and I can actually go out and just query it, which is pretty cool. I already have my credential created. I'm using the built-in serverless engine, which we'll show about that here in a minute. And it's just a way to quickly query my Cosmos DB engine, and I'm not incurring RU charges here. You guys are familiar with Cosmos DB RU charges. We're reading the analytical story back end that's already created these Spark files. And it's keeping them up to date as changes are made and process needed. Cool capability. All right, next. So that's data. Next piece is starting to get a little more interesting here. Is the data flows. Part of the data flows. So I've got a few data flows here. I'm going to show you a very simple one. Let's say you've landed all your data here. You want to put it inside of your raw zones. We have it somewhere out. You've got JSON data out there. A few different activities here. And what's interesting here again is that it's completely parameterized, right? So I have source table name, source and target table name. We don't care about schema. We'll do schema inference for you. So for any kind of JSON landing out inside of my Delta table, we'll get into what Delta is here in a minute. I'll take the JSON, but whatever it is, we'll do schema inference using a capability called schema drift. Don't care about it. I'm going to add some metadata columns through an activity, and there's many activities. Your common activity when you're building on a data lake is to add metadata information about where it came from. So when it came from, data inserted, for example, and then add it in. We're going to drop it into my data lake in a Delta format. So Delta, if you remember, is a ACID compliant transactional storage. Next, what I might do with that data, again, and I'm just completely schema agnostic, is to go from your bronze to silver zones. So what are the things I need to do there? Well, I'm going to pass this data flow 4 parameters: source name, source table name, target table name, primary key, and timestamp column. Right? Again, when I actually call this, I'm going to be triggering it and passing in those parameters to it. Completely schema agnostic. I don't care about what's in there. We're going to add some metadata columns. I need to actually define some hard column names, PK column, and timestamp column. I'm using the expression that I have from those parameters, by name, primary key, and timestamp column, which we passed in. We call that. I'll do a window function, which is another thing you can do here in data flows. And I'm going to do a window over the primary key column, sort of by the timestamp descending, do an unbounded range, and give me an rank the row version. So essentially what I've done there is, hey, for the primary key, give me the inverse of the timestamp, and then let's deduplicate. Let me give me the latest version of that row, and then remove my metadata columns. And this is essentially a sample type of bronze to silver, doing some basic, data deduplication. So what I have now, once I've done that, I go back to my area here, and I actually kind of look here, is that then my Synapse file system, I have a whole Delta area where inside of silver, inside for each one of these tables, and I just pass through these table names, and it does it again automatically. I'm going to get the latest version of that row sitting out there, and we'll get into the Delta here in a minute. And then similarly, you can do more transformations, and I don't know if we have any data people here that are interested in this, but do anything like dimension denormalization. Take a few tables, join them up, get rid of duplicate columns, that kind of stuff, adding surrogate keys. This becomes a little more tricky if anybody's used to doing this. In Sql, we have to use some key caching and a watermarking table to do surrogate keys, although identity is coming from Delta Lake. I don't think we have it yet. I know Databricks does. And then doing slowly change dimensions and other things. So you can do all kinds of dimensional modeling inside of this, and you can do other stuff as well, right? So I'm a data warehouse person. I kind of go there first, but you can do other things with data flows. I've used data flows. We had a customer that had an enormous DB2 database. They store time very weirdly. We had to come up with I think it was 6 or 7 different combinations of regex patterns to find anywhere where they did time and then convert it to a SQL format. And we could just do derived columns here, write regex instead of the expressions, and inside of here just do all the replacement. Then we ran through terabytes of data. So we did it visually, but behind the scenes, since it's Spark, we can give it a big cluster on the back end. So it's not just about data warehouse. Next, so Synapse Spark. So this room, I think, was some .NET people. So I wanted to do 2 things. Oh, you gotta be kidding me. Set my Spark cluster. So first off, I'm not gonna wait while we'll go right to serverless, but I'll let this one up. One of the important kind of concepts of Spark is that it's it can turn itself off when it's not being used. So you have to set the TTL essentially after X minutes of inactivity. I thought I had set it to 2 hours an hour ago. I guess I didn't click save. So you have to, the back end, you see I'm attaching this. What I have here is a notebook. If I'm familiar with Azure Post, but this is a really cool development environment. Inside of these cells, I have code. I can also do markdown between them. And I'm creating a new Delta table. I have attached a Spark cluster that I have defined down here, which on the back end, I've got a Spark cluster, I should say, defined by version of Spark. And inside of these settings, scale settings or pause settings, 5 minutes, I meant to say 5 hours. Oops. That's my fault. So after 5 minutes of inactivity, it'll turn itself on. So it's a good cost saving thing, but you can see what you could have to do if you are doing live development. It becomes a little bit tedious to wait for this thing to warm up every time. So we'll let that warm up. And then once that warms up, it'll be used, for whatever engineering I'm doing after that. Let's talk about Synapse Serverless. Does its thing, and then we'll get into this. So looking back to the dimension denormalization piece. So I'm going to go back to the data flow. I did silver to gold here. I'm going back to my data flow, doing dimension denormalization. Expand this out. There. On this side, you can see that I have a bunch of sources here on my left, some little transformations, which I just told you are doing some joins on these tables, columns. On the sync side, which is my output, you can see that I'm outputting to an inline data set of type delta. And so delta is interesting in that it's essentially writing out parquets, but parquet, that sort of columnar format that's highly optimized for big data storage. It's also at the same time keeping a log of transactions. So you do a couple things with delta. You can continue to write to it, upsert, delete, insert, whatever the case may be. When you delete a row or change a row, we don't actually modify the row. We'll just add a new row but put a timestamp on it and expire the old row. This enables a couple things. One is enables time travel, so I can go back and look at the state of a table that whatever kind of history I have inside of my delta table, which I think is 7 days by default, and you can modify that. But you can also time travels there. But you can also see and sort of have an audit of who's done what inside of your table. Pretty interesting. So what I've done there is, as I showed you, is I'm put into this gold product table inside of my blob storage account. I didn't show you this data preview piece. I should have, it's because it's a really important part of data flows. Is that every time you make a transformation, you can go to this data preview tab, hit refresh, and we'll sort of give you a live view of what your data flow looks like at that moment in time. So if I had another transformation out of this, you can kind of do live debugging these things. Very, very powerful. If you've ever done ETL development or work with this, I guess this is a game changer. So green lights just turned off. So I guess no one's moving. Yeah, so let's see if my my Spark cluster started up. All right, so a little bit about Delta. I wanted to mention that. So Delta is that capability of writing parquets. I declared a little build, a variable here on my session ID. I'm going to write a Delta table out to that path, just off of a range. So I'm just going to say, hey, give me 0 to 5, write a Delta table with those rows in it. And we'll look at that here in a minute. And you might notice I'm inside of this notebook. I chose .NET, but we can do things in Python, Sql, or Spark SQL, and I believe R is coming soon. R is one of those things that Databricks has here that we don't. So I was going out and writing my table. Earlier. Okay, cool. Typically doesn't take long. So anyway, you can see I wrote 5 rows. Right? Next, what we want to do is just kind of give me some information about this Delta log. So I'll actually show you inside of the lake. There'll be a parquet file. There'll be 5 Parquet files, and there'll be a folder called Delta log, which is going to have in JSON this sort of transaction log, which I have down here. See, as I'm writing these files, they're going into these individual Parquet files, this rows. I'm writing to a table, but under the covers is Parquet. And I'm also recording things like the modification times. So this is an ID of 0. So this is the first version of the rows. Think about that kind of going forward. I can read the data in the lake. Here, I'm just declaring my data frame by reading this delta in this path, and I'm doing a df.show, which is the data frame is a pandas data frame, which is showing the table. Then the next thing I'll kind of stop here is I'm going to update the table data for delta by just giving it another range, and we'll see that if I were to read the table again, it's going to be 5 to 9, right? When I go through 5, 7, 8, correct. And when I go through and look at that same log table again, that delta table, you'll see that I have the initial log down here for log 0 at that time, but and what we're writing at the actual IDs, 1, 3, 4, so on. You can see there, 4. Then at the top, you can see that as we're writing the rows again, we are updating them, essentially given a modification time. And kind of going down this works. So what's interesting is that if I were to go down, I'm going to do all the rest of the stuff. I'm going to read an older version of the table. So I want to read that delta table and give me a version as of 0. What I should get there is the initial kind of loading of that table, which is going to be 0. Right? So some of the other vendors out there, and I think a lot of people are using this now inside of their data lakes. Very cool capabilities from that perspective. All right. Yeah, that's Spark. Very exciting. All right, so that's notebooks. And a couple things, that's 2 things. It's Delta. I wanted to kind of talk about what Delta is, and I wanted to kind of give you an introduction to notebooks. And to Spark, right? So a few different pieces to kind of showing that data lake. And like I said, everything I have out here is out of GitHub, and you can go out and play with it. Parts Lieutenant, you have a Spark cluster to play with, and that may or may not be a thing for you. But yeah, that's I think pretty cool capability there. Lots more to Spark for sure. There's streaming, which sort of works in Synapse. It's better than Delta and Federated at the moment. So there's there's a lot of capabilities there, and this is kind of your code forced data transformation tool. We didn't really get into data engineering in Spark, but you can do the same thing I did in Data Flows, do that in Spark instead. Do SQL, do a Python, whatever you want to do. I did a hack open hack with customers last week. My whole team were all Python developers. They got right in here. They'd only ever done local Python in Jupyter. They got right in Spark, and they were doing data engineering first day. So if you've got that skill set, you move right into here. And I have to say, most people kind of coming in right now, certainly know Python. But we can meet you where you are. You can use .NET or SQL or Scala too. And there's like 2 people that know Scala in St. Louis. Okay, and Steve and I know both of them. Okay, so the next thing we were talking about was the serverless. While I was waiting for that to spin up, was the serverless piece. So inside of this dimension denormalization, you saw that I wrote this all out to this delta table. It actually is writing it to a quote database. So I'm going to go to my data hub here. Here we're getting into the serverless piece. I've created some databases. I have a Ron's database, a Bull database, and a Snowflake. And you can use SQL Server Management Studio. It'll be right here. You notice that I'm connecting to my on-demand endpoint. And this is old SQL Server Management Studio. It has nothing to do with Synapse. You can see these databases in here. You can see the tables in there. I have a dem product table that you use in query. So really powerful external table. Really powerful capability, and that Synapse here in the back. As you create these external tables, they're just available for people to query. So we're going to use that Synapse serverless. I'm doing nothing weird here. I'm not doing any kind of open row sets. You don't have to change your queries. You create views. You use stored procedures. And this is essentially metadata defined over my Parquets inside of this dev product folder, which if we go wait for this to execute, about 20 seconds back for this particular table right earlier. Something. Okay. Big query, so there it is. Okay. So it looks and feels like SQL, right? And you can give people access to that, use Azure Active Directory to access whatever you want to do there. Serverless is, rest assured that if you are kind of thinking about designing around this is something we're going to be thinking about. So really cool capability. We're only going to be getting better and faster here. And this wasn't particularly quick, but I'll show you a pretty cool data. There's a lot of data here in a second, which is coming up right now. The next part of it is using the serverless piece, not as like a logical data warehouse, but think about data exploration. So I have inside of my develop hub, which I'm going to, I can also save SQL scripts out here. So I can go out and query very, very large data sets using the built-in serverless query engine. And what's interesting is that I'm going to be looking at a set of data that's freely available. I'm using some wildcards you might notice inside of my statement where I'm actually looking at all of the years for 2019 inside of my lake, give me all the Parquet files back. As I see. So that's an account one on top of that. So we have 44 million rows inside of a bunch of Parquet files sitting out in this path of the lake. You can also do query predicates. Hey, give me location ID, 234, all the pickups in 2019. No database in the back end. I just queried over 44 million rows across 8 gigabytes of Parquet files, I believe it is, to go and find that and do a simple query. So think about data exploration. What's in my lake? I can write common T-SQL across it. And then also, should it derive value from that? We can also do things like aggregations, other types of queries, and use these kind of file paths inside of our query predicates to get value out of that as well. Got no results back there. Oh, it's still running. So pretty cool, very powerful capability. Here I'm looking across many, many millions of rows. I need to comment on that, but you can see that bytes per year sort of declined starting in 2019, which you might guess why. Came in around here. Right? So that yellow taxicab data. But you can do other more powerful things here. You can do something called Federated Query. And I'm going to move over to another environment. I'm looking inside of a Federated Query using serverless database. I'm looking inside my data lake in a Parquet file. Looking at a Spark database, which is shared with serverless. It's banned users inside of a Spark table, as well as Cosmos and using Synapse Link. And I'm actually going to be joining all of these various remote locations together into a single query and querying across that. I've done no data movement. Everything is just attached to Synapse. So I'm going after a remote Cosmos table, after a Spark table that I've defined, as well as my data lake, and doing some basic query predicates. But you can see this is a very, very powerful way to do some really cool, quick. And it's kind of that point that I made at the beginning is how do you do quick time to value on these types of things? I mean, to load all this stuff into the data warehouse could have taken weeks, or in a couple of weeks, maybe to find all this. I've done zero schema. I've done nothing other than just laying this data. Okay, for my Twitter users, it's literally Twitter. It's all live Twitter coming in. And then if I'm joining it as a fan, people have been cussing and saying other bad things, and then also joining into a Spark table for looking at some user data joining. Pretty cool capability. And then I can also just save this as a view. Say, hey, I'm gonna make a view out here, and it's sitting out inside of my serverless database, and I don't have to tell anybody that thing. Just use select star from the view command, right? So really cool. Again, I could give someone access right now in Power BI in the wrong database. I can never remember which one it's in. There's a bunch of service database anyway. You can save it to view, trust me, it works. I thought it was in serverless database. This is shared by a bunch of people. case being is that you can immediately say, hey, yeah, all that data you wanted, it's all, it's in this view, you can attach to Power BI. Good to go. Pretty cool. All right. Serverless, is that landing with anybody? Does that look interesting? Last thing, kind of one of the last things I'll show is the dedicated pool, right? So this is just SQL, very powerful. I'm not even spun up to that big of an instance. You've been around Sean Netzer in the last 6-7 years. It's probably showing you something similar. Everybody knows Sean Netzer, querying billions of rows. Here I have a 12 billion row table, and I did a table count back in 5 seconds. I'm going to do a giant join across some dimensions and some of those things, similar tables across 12 billion rows. Just count back in 2 seconds. And I'm only scaled up to, I think, the DW 500, which is very small. But if you've got this thing tuned correctly, it can be enormously fast. The right type of analytical, not meant for row-based operations and stuff like that, or transactional software. It's analytics. So yeah, that's that piece. Kind of end to end on Synapse. We've got monitoring built in. Inside of here, both triggered and debug runs. I haven't run anything interesting inside of that Synapse environment. Pop over here. Monitoring's there. Look at pipeline runs that are triggered. Dig into what's actually happening to all of them. Look at all of your input and output conditions. What's happening from the perspective of monitoring there and trigger how many rows you're copying and whatnot. So that's built in there for each individual Synapse environment, but you can also, within your going back to the portal here, inside of your diagnostic settings, pipe all this back into centralized log analytics for diagnostics across all of your Synapse environments. And coming soon for me is we have Grafana, if everybody's familiar with Grafana, we have managed Grafana now, I have a demo that I'm building to show analytics on top of all this. And then the last thing to kind of wrap this up is, I talked about the capability of, having branching and, collaborative development. All this stuff gets wrapped up on the back end, and we have, full, I'm switching over to Azure DevOps here. We have full support for CI/CD. We have a native activity inside of a release pipeline called Synapse Deployment Tasks, which will move all of your assets between environments, data and QA and so on. All right. I know I'm talking fast. I didn't want to take up too long on this.
There's one question.
Is there a question? Yeah.
Question on Polybase. How does Polybase fit into this? I've heard it is in dedicated pools. Do you recommend using Synapse Pipelines instead of using Polybase for moving?
Yeah, yes, and yes. So Synapse Pipelines will use Polybase on the back end. There's 2 different ways you can do ingestion into a dedicated pool. You use Synapse Pipe, you can use the Polybase, which is fine, but we now have the copy command, which I may have that, which is as fast or faster, and this is essentially where we're doing everything now. It requires fewer permissions. Have an example of the copy command. And inside of a Synapse pipeline, you'll see an option when you have your sync as Azure SQL Data Warehouse or Synapse Dedicated Pool, an option to either use Parquet or copy, which is the open row set command, or Polybase. And right now, I'm having everyone go to copy just because it requires fewer permissions in the pool. I can't remember what they are off the top of my head. Someone can put in the chat, Steve, and Steve, whoever. But the answer is yes, but also please look at the copy command because that's where the feature is.
Let's say we did Azure Data Factories for maybe our bronze and silver level of the data. Is it easy, if we should have went to Synapse, easy to take the Git part of the JSON and put it into a Synapse?
Yeah, you can literally just take you can export it out, import it in. We have a tool to do that as well.
Okay.
It's not like super easy, one-click button, but yeah. Back end, it's all the same JSON.
Okay, so.
If you just need to do a pipeline at a time, for example, you can just go to your ADF pipeline. Like I just actually moved that incremental copy demo over, export it, and then import it. Right. So if you want to do everything, you can do that way. But if you just want to move over a subset of your pipelines inside of your ADF environment.
Well, for VNets and everything, you just use integrated runtimes or private endpoints in this Synapse like you would Data Factory?
Yes, yes. It does support private endpoints, yeah. And in fact, The last slide, I'll put a link out to here. There's a guy who's kind of written a good kind of end-to-end analytics where Synapse fits into kind of the whole analytics platform in Azure. He has a really cool deployment template that'll deploy this stuff for you or not. You can kind of select everything you want out of the whole picture, and you also can say, yeah, I want it all behind a private link, and it'll do all the editing for you and all that kind of stuff. A lot of people don't want to use that in their environments, but it's a good example of how to build it. But everything inside this gray box is kind of what we're talking about here today for Synapse. Thanks, Steve.
I was going to read out that question, but he answered it. So it was about Azure AD integration.
Yeah.
Permissions.
Does it already use managed identities and everything?
I'm sorry?
Does it already have managed identities built in? Kind of how?
Yeah, absolutely. Kevin, thank you for asking a question. I know that people are there listening to me. So, yeah, you can just, oh yeah, if I want to open this pipeline, I can go up here. Where is this? Export template. So that's a specific pipeline. I can do the export template and then import it back in. But then on the back end, obviously, this stuff is the same. If you go here, branch. The difficulty is that pipelines depend on linking services, depend on integration runtimes. There's all these interdependencies. So trying to just bring over one piece, it's easier to maybe just export as a template and then re-import it back in.
Yeah, just do the sync and sources yourself. Makes sense. Just redo the sync and sources in the tool then.
Yeah. Yeah. So yeah, like for example, if I wanted to re-import a pipeline here, actually a couple of things I should show you in Synapse. We actually have a whole gallery of pipeline templates here, which do a lot of these common kind of data transformation and loading kind of tasks. Some SQL scripts as well. Some common notebooks that have things from like machine learning and other things. I didn't show you the machine learning stuff because that's a whole other topic. But there's built-in machine learning models to do things like sentiment analysis and anomaly detection. You can do your own model training as well. And then you can use like internal libraries like Synapse Spark. We have built-in, common data sets you might want to use. Both database templates, which this is a whole other conversation where we have, it'll essentially stamp a schema on your lake for you to be data in, and then it'll spawn a data flow, kind of loosely reports to you on that data mapping. Letting out that data.
You did that?
No, we should.
So that's it from me, from Luke. Thank you for listening. I know we have like 3 people here in the room. Good times. Any other questions? Appreciate everyone being attentive and asking questions.
If anybody does have any questions, you could tell them to reach out to me or I'll get a hold of you. Or...
Yeah, I'm going to give Kevin the links that I have here. I had a couple more things that I wanted to add. I'll make sure to stick my repo up to GitHub and put the PDF of these slides up there for you. Yeah. Hopefully I'll see you at DevUp conference in person. Yes.
Did you announce that?
Yeah, I did it in the chat. There's a total people here.
Got left. So thanks, Kevin. Thanks, Steve. We're gonna probably close it down here. Who else in the room? Mike?
I'm out.
We post it to you. What? We post it to you tomorrow?
Yeah. I'm going to give it to you.
Thanks, folks. We're ending up here. See you next time.
Thank you very much, man.
Thanks, guys.